Okay, here are your answers to question 1, part A. 0, the most obvious one, and these two others which I will explain. Notice that I've simply factored out an x from each of these terms. This is essentially using the distributive property of multiplication in reverse. Clearly, x equal to 0 makes perfect sense. If you plug in 0 for x, we have 0 multiplied by the rest of the expression, and that results in this entire expression being equal to 0. 0 equal 0. True statement. By the way, that's what we're doing when we are solving these equations. We are making this a true statement. Is this equal to 0? Well, only when we have these three solutions. Right? So let me get back to explaining the next two. Now this second part is very important. When this thing is equal to 0, once again we have 0 multiplied by the other expression, thus making this a true statement. And so, if we look carefully, we can see that plugging in square root of 2, we end up with 2 minus 2 equal to 0, and at the same time, plugging in negative square root of 2, we get the same result. Of course, we can also do the algebraic process that is more familiar. Take this expression right here, and we'll solve for when this is equal to 0. So we subtract 2, or I should say add 2 to both sides. Then we take the square root of both sides, and we're done. Here are your answers to question 2, part B. So notice, once again, I'm able to factor out something. I can factor out x squared, like this. Now I end up with this expression, making it a bit easier to find these answers. Clearly, once again, x equal to 0 gets the job done. 0 times 0 equal to 0. And now we would like to figure out when this expression is equal to 0. Now one thing we can do is say, alright, well look at this 3. Wouldn't it be nice to get rid of that 3 and then figure out what x is supposed to be? That is what we generally do algebraically. Let me show you this little trick, however. So 3 multiplied by, alright, something over 3 plus 2 equal to 0. Getting closer to what the answer is going to be. Well, these 3's are going to cancel out. Hey, check that out. So our answer is negative 2 thirds, I should say. When we plug in negative 2 thirds into this equation, we get 0. Now we will do this the traditional way. Okay, so let's solve this the way that we are used to. 3x plus 2 equals 0. Subtract 2 from both sides. Divide both sides by 3, which by the way is getting rid of that 3. X equal to negative 2 thirds. And we're done. Okay, now this is interesting. For 1c, here are your two real number solutions. And if we are also looking for complex number solutions, we get these two additional solutions. Plus and minus root negative 3, or in other notation, I root 3 negative I root 3. First we will focus on the real number solutions. Now first let's just think about this logically. Root 3 squared is 3. 3 squared is 9. So root 3 squared is 3. 3 squared is 9. So if we were to write it like this, root 3 squared squared, we're squaring it twice, that's going to be 9. Well, what is another way of representing this? This is root 3 squared multiplied by 2, and that's because we have this exponential right here, and this of course is going to be equal to root 3 to the 4th, and we know from this analysis right here that this must be equal to 9. And so logically we've discovered that root 3 is an answer. And now because we have a positive exponent, we would also know that negative root 3 would be an answer as well. And with a little bit more thought, I is the square root of negative 1, and if we take that to the 4th power, I or negative I, those would just turn out to be 1, and these would be answers as well. Alright, now let's do this the more traditional way. Now here we go. Let's add 9 to both sides. X to the 4th equal to 9. What we're doing is very similar to what I was doing before. Now let's take the square root of both sides. And this is going to be equal to x to the 4th. Now recall one thing, square root is the same as 1/2 power. And this is equal to 3. This is equal to x to the 4th multiplied by 1/2, and that's going to be x squared equal to 3. What's one thing I just forgot to do? Plus or minus 3. So we have x squared equal to plus or minus 3. And let me just mention over here, you can remember the square root of 4 itself is 2. That's one way of thinking about that. Okay, now let's go back to this. X squared equal to plus or minus 3. Well, this gets a bit interesting. So suppose x squared is equal to 3. Well, we can solve that easily, and the answer makes sense. Take the square root of both sides, and we get x is equal to plus or minus root 3. Now let's look at why we can get these complex number solutions. Recall what we did here. We end up with x squared is equal to plus or minus root 3, and we dealt with the positive case. And if we are only dealing with a real number system, then we can't have the negative case. But if we are to allow the complex number system, then we can deal with this case. And we take the square root of both sides of this, and then x is equal to plus or minus root negative 3, and the other notation for that shows up this way, plus or minus root -1 times 3, and root -1 times 3 separates out into root -1 times root 3, and that means that this right here will become plus or minus I times root 3, and that's because I is the notation for square root of -1. Still, the important thing to focus on is the real number solution set, but I just wanted to thoroughly explain that to you.